Video 2, question 21. Sn is 5n plus 2n squared. What is the value of T3? The question really asks us to find the third term of a particular pattern or sequence. We don't have the first term. We don't know if there's a constant difference or a constant ratio or maybe a constant second difference. But what we have been given is a sum formula. We're going to use that sum formula and first just in general write out what it would mean. Sn simply means the sum of the first n terms. That would be term 1 plus term 2 plus term 3 plus however many terms there are in this sequence. And so for us to find the third term, we're going to do something very clever. We're going to say, well, at least we can write out what the sum of the first three terms would be. That would be term 1 plus term 2 plus term 3. And we can also write out what the sum of the first two terms would be. That would be S2 is T1 plus T2. Now consider what you have here on the screen. If you look at the two expressions or the two formula that we've constructed here, the sum of the first three terms and the sum of the first two terms, if we subtract from the sum of the first three terms the sum of the first two terms, then we are left with the third term. Alright, so I will say again, what we do is we say, if we take the sum of the first three terms, that is term 1 plus term 2 plus term 3, and from that we subtract the sum of the first two terms, that would be minus S2, that would leave us with the third term, term 3. And so that's exactly what we're going to do. S3 minus S2 is equal to T3. And so the formula that we have, Sn is 5n plus 2n squared, is equal to S3 minus S2. S3 is 5 times 3 plus 2 times 3 squared minus S2 is 5 times 2 plus 2 times 2 squared. I'm literally just using this formula twice, first for S3 and then for S2. And that would be equal to 5 times 3 is 15, 15 plus 2 times 9, that's 18 minus 5 times 2 is 10, plus 2 times 4 is 8. That would give us 15 plus 18 is 33, minus 18, which is 15, and this is the third term. If we go back, we see the answer sits right here. Of course, in general, something that we can also do is for us to remember that we can in general say that if we want to use this formula again, we would be able to say the sum of n terms minus the sum of n minus 1 term would be equal to the nth term. Just like S3 minus S2 is equal to T3. And so this is a lovely little formula to remember that you can use in the future. Alright, we move on to a completely different type of question, and what we have here is the log of 16 divided by the log of 64, and 4 possible answers are given that we have to choose from. And so what we're going to do is we're first going to look at the log laws, and the log laws that we're going to consider would be, the first one that we have here is the log of AB is equal to the log of A plus the log of B. The second one, the log of A divided by B, is the log of A minus the log of B. Easy to remember, when we multiply, we add, and when we divide, we subtract. That's for the first two laws. The third law, we often use that in financial math. The log of A to the n is n times the log of A. Unfortunately, you need to know these off by heart. The fourth one, log of A base t, is log of A divided by the log of t. And those are the first 4 log laws. Now, if you consider the second log law here, the log of a divided by b is the log of a minus log of b. One feels tempted in this case to say, well, then surely this is the correct answer. Log of 16 divided by log of 64 is log of 16 minus log of 64. But if you consider the expression that I've just circled there for you, and you consider the second log law, you can see that it's not the same. In fact, what we have here is the log of a divided by b, not the log of a divided by the log of b. So this is definitely not the correct answer. Rather, what we will do is we will say the log of 16 divided by the log of 64 can be written as the log of 2 to the power of 4 divided by the log of 2 to the power of 6. So I simply write the log of 16 and the log of 64 in terms of the log of basis of 2. What we can now do is we can now use this log law. The third one that I wrote for you, the log of a to the n is n log a. And that's exactly what we will be doing. And so if we go back, we can write the log of 2 to the 4 is 4 times the log of 2. And we do the same at the bottom, the denominator. The log of 2 to the 6 is 6 times the log of 2. And then what we do is we simply say, well, that would be the log of 2 divided by the log of 2 is eventually 4 over 6. And 4 over 6 is equal to 2 over 3. And there sits your answer.